Okay, today we're looking at ALEKS, Algebra 1, Functions and Lines Pi Slice, specifically comparing linear functions to the parent function y equals x topic. So the first thing that we need to take a look at is what does y equals x look like on a graph? Now in ALEKS we're going to be given a scratch area. Since I don't have that on here because this is just a screen grab of an ALEKS question, I'm going to show what it looks like in Desmos. So we should know that y equals x is the basic linear function. So it is a straight line at a 45-degree angle with a slope of 1/1, and it crosses the y-axis at the origin. Okay, so this is going to be our parent function for every single problem that we're dealing with in this particular topic. So I'm going to leave that up as my red line, our parent function. In each of the questions, it's going to ask you to complete two statements about two different graphs. The first statement is going to have to do with the steepness, and the second question is going to have to do with the y-intercept. So we need to be able to examine each of the equations. So in the first equation, we have y equals negative 3x, y equals negative 1/3 x, and we're comparing that to the parent function y equals x. So we already have the parent function y equals x graphed on Desmos. We want to take a look at y equals negative 1/3 x and see what that looks like relative. So I'm going to go ahead and type that in exactly as it appears in ALEKS. So y equals negative 1/3. Make sure that my x is next to the coefficient and not potentially underneath next to the 3. Okay, so it's negative 1/3 x, not negative 1/3x. And notice that that gives me a blue line that has a negative slope, so it's decreasing from left to right. Notice that it also crosses at the origin, so we're going to need that information later on. Notice also that it is less steep than the parent function y equals x. Y equals x is more steep, so it rises at a greater rate than the y equals negative 1/3 x falls. Okay, we'll talk a bit about that here in just a moment. So on here, compared to the graph of y equals x, the graph y equals negative 1/3 x is less steep. Okay, so it's less steep than y equals x. And compared to the graph of y equals x, the graph of y equals negative 1/3 x intersects the y-axis at the same point. In this case, the origin, 0, 0. Okay? Now it's asking us to compare the graph of y equals x minus 1 and the parent function y equals x. So y equals x minus 1. So I'm going to replace y equals negative 1/3 x. I'm going to call it y equals x minus 1. Okay? Notice that we have a graph with the same slope. Okay? And we should be able to see that in the equations themselves. Notice there's no coefficient on x, so that means that my slope is 1, or 1/1. But this time I have a y-intercept of negative 1, crosses the y-axis at negative 1. So the slopes are equally steep, they're parallel to each other, and it crosses the y-axis at a lower point. So I have a graph that is equally steep, and compare to the graph of y equals x, the graph of y equals x minus 1 intersects the y-axis at a lower point. Okay, so remember, in an equation that's in slope-intercept form, y equals mx plus b, my b is my y-intercept, and my m is my slope. Okay? The closer a slope is to 0, the less steep it will be. So notice that negative 1/3 is closer to 0 than 1, which is why negative 1/3 is less steep than 1. So y equals negative 1/3 x is less steep than y equals 1x. Remember, if we have no coefficient, the assumed coefficient is 1. So negative 1/3 is closer to 0 than 1. Therefore, negative 1/3 is less steep than 1 when it comes to slope. 1 and 1 are equally close to 0, therefore they are equally steep. If I had a function something along the lines of y equals 5x or y equals negative 5x, both of those are further away from 0 than 1, so both of these would be more steep than y equals x. Okay? Likewise, when we're talking about where it crosses the y-axis, if this is a negative number, it's going to be lower. It's going to cross the y-axis at a lower point. If it's a positive number greater than 1, or excuse me, a positive number greater than 0, it will cross the y-axis at a higher point than y equals x. Y equals x is the same as saying y equals x plus 0. Okay, there's nothing there, so therefore it's the same as saying plus 0. So if I have any number greater than 0, okay, any positive number, it will cross the y-axis at a higher point. If I have any negative number, that is to say any number less than 0, it will cross at a lower point.